false negative stuff.
Prediction quality?
Yeah, prediction.
Yeah, quality
Official history.
It's a capital market thing.
So I have the folders and you want to add it to the new folder. Like when I download them, are they in?
Okay, no, go to Excel. Did you save them in a new folder?
Yeah, they're here.
Okay, go to Excel.
So
File.
And indirectly, they need the same for the professor as well.
Go.
Okay. Can anyone send me the lecture about quality of prediction?
Uncheck that.
There is a very important slider, and I want you all to see
and
it.
then in my folder, find my.
Again, my email address is here.
Kobe, at some point also you have to run Monte Carlo.
We can do the next thing that we can do is
And then do
today.
that
He's from Joe in fact said that it was important for us to know what lecture exam.
So let's do
He
four.
said that.
So let's finish with the quality of prediction, and then
You want to email it?
and then I hope we will be able to do.
It's a like quality
I think we'll be able to do also optimization. I think this is.
And then do that.
I think this is the
No, that should be the one that you
do quality of prediction, simulation.
This should come.
Good, thank you.
Okay. Guys, can anyone send me that?
There, you have
Yeah, I'm
it.
sending it.
Okay, so how do I know if it's the new one?
It should be, because I think just by downloading the new, it should be part of your admin, I think.
Where?
You think I go to the chapel though?
We'll see.
What's the email address?
It's YMA
I don't know yet. I don't have anything.
TSRI@gmail.com.
Kobe, when's your tentative marketing session? When is it?
I don't have a room for that. So if anyone can find a room for that, it would be great. Probably not in URIS because everything is assigned to exams. So I don't know when it would be.
So we don't
I
know.
want to do it in Wednesday, it's free, but only if I will be able to find a place to do it, because otherwise I can't do it.
I sent it.
Okay, so
Wait, what session is it, do you know?
I have no idea.
Session 4.
It's all the false positive, false negative.
With prediction quality?
Are you sure? Are you sure you said it?
Yeah, it's that.
Quality of protection, he's asking for the Tahoe. Yeah.
I know. I hate the name.
Let's speak in general until it will arrive. Let's say that you are running a company. You are running what type of company? Anyone have a preference? We are running a restaurant, okay? And you want to hire a waitress for the restaurant, okay? And different people are coming to you, and you need to decide to hire them or not to hire them. So, now, the way you decide if to hire someone or not is based on his GMAT score, okay? And you have some type of threshold. Say, hey, if he got more than 600, I'm hiring him. If less, I'm not hiring him. Now, once you decided about the GMAT score, the threshold, you have two types of errors. One error is when you decided to hire someone, but he was not good enough. And for example, you need to pay him a year of salary, you need to fire him, it's a big like cost for you. And the other type of error is when there was someone that is actually already good, but you didn't hire him because he didn't have good enough GMAT score, but he's actually can be very, very good for the job. Okay, makes sense? Okay, now what I'm always confused about is
Where?
yeah.
Oh my gosh.
So there is a specific slide I want to see here. Okay, here you have all the definitions because it's very hard to actually remember it. So one type of error that you predicted that the guy is not good and he's actually good. So you predicted negative and you were false, so it's a false negative. And the other type of error is a false positive. You said positive and it actually was a false, it was a negative, okay? So the second word is what you predicted, and the first word is if you were right or not. But just have this, because it's open material, you can just have this table, and everything is great. Okay? Now, usually in questions, what you will need to do, you will need to decide about the threshold. Should I hire if someone has more than 600, 550, 650, 700? What will optimize my profits? Okay? So we have some type of profit or loss in each of these cases, and I will try to maximize it. We'll do it. We'll do it. Some definitions. Total error rate is the number of false positives plus the number of false negatives divided by the total number of outcomes by the sum of all these tables. Okay. How likely, and the false positive rate is the number of false positive divided by total number of actual positive, negative. So, number of false positive, this number, divided by the sum of this line, okay, not overall thing. And the number of the true positive rate is the number of true positive divided by this, the sum of this line, okay? Just definitions, and so I think this slide, you can always have it, you have also type of example. So in the exam, if you need to do something like that, always open this slide and make sure that you're using the right formulas and that you're using the numbers. Okay, let's speak a little bit about the hours. This is a better figure. So the y-axis will be the true positive, and the x-axis will be the false. Let's just say it in words. This false positive is people that said, hey, he's okay, but I was wrong. And the true positive is the people that I said, yeah, I want him, and I was right. I want the highest number in the y-axis and the lowest number in the false positive axis. Okay? So the best thing that I will have, I want to have a point here. 100%, I want to have 100% true positive and 0% false positive. And of course, it's usually impossible. Okay. So now every type of model that I will use will give me a different curve in this graph. What do I mean by that? If I will use, for example, for the example of the restaurant, if I'm using the GMAT score, I will get a curve like that. Let's speak about it for a second. First, for every curve, or not for every curve, but usually, I will have the 0 and 0 point. Why the 0 and 0 point is very easy to achieve? How can I achieve 0 and 0? 0 false positive and 0 true positive. How can I achieve that?
Are you refraining from making any decision?
I always make the decision of no, I'm not hiring him. Anyone that is coming to me, I'm not hiring, not hiring, not hiring. No matter what he said, no matter what his GMAT. So the false positive will be 0, if they didn't make any mistakes with this type. The true positive will also be 0, so it's not so good. Okay? What about 100% and 100%? I can also achieve this point very, very easy. How so? I will accept everyone. So out of the good people, the true positive will be 100%. Everyone that is good, I actually hire him. On the other hand, I also hire everyone that is not good. So every model will usually have this point 0 and 0, and this 1 and 1. The question is what happened in between. So for example, if I am with 50% false positive, how much of true positive I can get? Okay. Now there is one curve, it is the straight line between 0 and 1, you can see it on the graph also, that is also very easy to achieve. If I want to have 20% false positive and 20% true positive, I can achieve it. 50% and 50%, I can achieve that. 70% and 70%. How can I achieve that? Just by tossing a coin. Everyone that is coming to me, with 50% I'm accepting him, with 50% I'm not accepting him, I'm not looking on the person or doing anything, and I will get this point, 50 and 50. Is that clear? Or 70 and 70, or 80 and 80, or 90 and 90. So this curve, like, if I have a curve, a model that is less good than this curve, is to the right of this curve, is worth nothing. Because just random give me this curve. Is that okay? Makes sense? Okay. Now let's speak about the GMAT. The GMAT model, if I'm using the GMAT in order to decide if someone is good or not, I can use different thresholds. For example, I can have only if someone have 800 score to hire him, and then I will not hire anyone. And then I can lower my threshold, and I will get this type of a line when I'm low. So this is the quality of predicting based on GMAT. Now I can predict based on another example. Let's say that I can predict on how many years of experience the waiter has. And then I will maybe have something that is different. Okay, something like that. Which curve is better? It's not fully clear, but it's saying that the years of experience is a little bit better. Okay? The best curve will be something like that. Jump very, very fast to 1. Something like that. That I can get very, very high true positive with low false positive. So the way I measure different curves is by something that's called AUC, area under curve. So if you think about it, the area under this curve, the random curve, is exactly half. Just because of rules of like triangles, this is 1, and this is 1. So 1 multiplied by 1 divided by 2 is 50%. It's 50% of the area. This curve, the GMAT, maybe it's 0.6. Maybe this one is 0.65, and this one that I don't know what it is 0.8. Okay? So the higher the area under curve, I am happier. The model is better. Any questions? Okay, it's clear? Great. Let's solve a question. Okay, so on different people, I have some score that I got using a log regression. It doesn't matter how I got it, it's actually from a previous question, but this is the score. Okay, this is actually what the model, the log regression, think that is the probability that this guy will be a friend of mine. And this is if he's actually a friend or not. So I have the real data. And now I want to check how good the model is. Now this is one model. I might have other models that give me other probabilities, and a third one that is giving me other scores. Okay, this is just, don't think about it as a probability, just think about it as some type of score that one model gave. Let's start the question. So, if the threshold of recommending a friend is 0.3, how many users would be recommended as a friend? So, just a question of how many people of this are more than 0.3. There's two ways to do that. The easiest way is to use a function in Excel called COUNTIF. I just give it a range. And I'm asking, hey, what is the probability that it's more than 0.3? It's 27. Or count how many is 0.3. What else I can do? I can use it in the longer way. Can add a prediction, okay, based on 0.3. Let me write here 0.3, because maybe I will want to use it, change it. And then I'm doing the following. If this number is lower than 0.3, then no. Otherwise, yes. So this will be, this for example, this guy, the prediction is that he's actually a friend of mine. Okay? Now I can drag it all the way down. And I can see sometimes I have some, sometimes I'm correct, sometimes he's not a friend of mine, I think he's a friend of mine. And this was just for 0.3 as a threshold. I can change this threshold to 0.8. Then you see I will make much less prediction. What makes the most sense? Probably 0.5. I don't know if this is the best, but 50% sound like something that is a good threshold. Okay. And then I can, of course, I can sum. I can do a sum of all of this to understand on how many people I estimate that there will be my friends. 27. What percentage of users recommended as friends in part A are actually friends? So, what percentage of the people I predicted that they are friends will actually be friends? I can do it using different methods. One method that I can use, do it, and I will show you other ways using their formulas, is I can sort this table based on the prediction. Okay? And then all the people that I predicted that they will be friends, I can see them together. And then I can, for example, or count by just looking and count, hey, 1, 2, 3, 4, or by just taking a sum. Of this. Again, this is one method. I will show you how to do it in a shorter, in a faster way, but I do want you to see both to really understand it. So you can just count it and see how many people that were my friends, that I predicted they are my friends, were actually my friends. Okay? I can do also calculate how many zeros. Now, let's go. So, let's go to the lecture, and you will tell me, what did I calculate now out of this number? How many people I predicted they are my friends, and they are actually my friends. So what I found now is actually the true positive. the number of true positives. Okay? Okay. Now, what can I do? What I can do? I can just create this matrix using a formula that they have. You know, remember the formula? Confusion matrix. So, confusion matrix. And again, I'm going to here because I don't remember the actual. So the actual is this column. If he's actually a friend of mine. And the second is the prediction. And as you can see, it's 5 and 4, so I go 5 down and then 4 to here. F2, Control Shift and Enter. You can see that this 16 that I got, I could actually just get it from the table, from this 16. Okay, because this is the people that I predicted that they are my friends, and they are actual my friends. Any questions? It's not complicated, right? What is the false positive rate for the threshold using part A? So, false positive rate. So if you remember, it's the false positive. So false positive is something I said is positive. My prediction was 1, but it was actually not, it was false. So it's this number, divided by the sum of this column. So you divide by 22. So it's 50%. Make sure that it makes mistakes. Yeah, see. Okay, they also asked me